In this video, we're going to learn how to graph the cosecant function. So I drew a nice t-chart and a nice unit circle without any of the labels, except for the labels of the angle in radians. And I provided, you notice as we go around in a positive direction, I have positive angles, and then as we go around in a negative direction, I have negative angles. You'll also notice for some of the angles, sine is positive in quadrants 1 and 2, but negative in quadrants 3 and 4. So I know that, for instance, the sine of negative pi over 3, which is this angle right here, and the sine of negative 2 pi over 3, they make the same 30, 60, 90 triangle, so they have the same sine function. So I created a t-chart that has some of my angles paired up, the ones that have the same value for sine. So I paired up pi over 6, 5 pi over 6, then I paired up pi over 4 and 3 pi over 4, and I paired up pi over 3 and 2 pi over 3. Same in my bottom two quadrants. So I'm going to use these values. I calculated the sine value of each of these, and I know that cosecant is the reciprocal of sine. So I calculated those values, and I want you to notice here that I have two places on my circle where cosecant is undefined. It's undefined when my angle is 0, so I know when I have undefined values, I graph an asymptote, and I have to label it with its equation, and then also at pi and negative pi, I have an asymptote as well. I will label that with their equations. All right, so now what I'm going to do is I'm going to graph each of my cosecant's values. So I'm going to start at pi over 2 because that's a nice easy one. Sine of pi over 2 is 1, so when I take the reciprocal, cosecant is 1 as well. So I'm going to graph that. And then I know at negative pi over 2, my sine is negative 1. So when I take the reciprocal of negative 1, I get negative 1. So now I'm going to go ahead and do my values at a half because they're really easy. I know at pi over 6 and 5 pi over 6, sine is a half, so cosecant is 2. And then at negative pi over 6 and negative 5 pi over 6, sine is negative a half, so cosecant will be negative 2. All right, well that was not graphed correctly, so let me move that over a little bit. All right, so how do I graph the other ones? Well, I know at pi over 4 and 3 pi over 4, the reciprocal square root of 2 over 2 is approximately 1.4. And then same at negative 3 pi over 2 and, negative 3 pi over 4 and negative pi over 4. And then at pi over 3 and 2 pi over 3, it's about 1.2. And negative pi over 3 and negative 2 pi over 3, it's about negative 1.2. So when I go ahead and draw my graph in, again, I get what looks like these little parabola looking things between my asymptotes. Okay, but this time secant had these parabola looking things, the two end ones were cut in half. Cosecant does not. All right, so I want you to notice that if I graphed my sine function would actually look like this. And so I can use my sine function to help me graph my cosecant function. Wherever my sine function crosses my vertical shift, I have an asymptote. If my sine function is down, I have a parabola looking thing that faces down. Okay, whenever my sine function is up, I have a parabola thing that is facing up. All right, so I'm going to use that to help me graph my cosecant function. Okay, so things that you should know about your cosecant function. Y equals C plus A cosecant of B times the quantity X minus D. That's the standard form of the equation. Again, we have vertical shift is my C value. Cosecant does not have an amplitude, so my A value constitutes the stretch or compress factor. My B value helps to determine the length of each period, and D is my phase shift. My period is calculated in the same way that we calculate sine. It's 2 pi over B. We graph the sine function first using a nice dashed line. Then we draw in asymptotes where the sine function crosses the vertical shift. Our cosecant will never have an amplitude because its max and min values are infinity and negative infinity. They are unbounded. And then our cosecant will never cross the x-axis unless we're doing a vertical shift that is 1 or greater up or 1 or greater down. Okay, so let's go ahead and start with an example. We're going to go ahead and change our equation into a sine function. And then our function is set up correctly. We're going to go ahead and find everything we need to for sine. We know for sine we have an amplitude of 3/2. We have a phase shift of pi over 2. We have B is 1, so our period is 2 pi. And then we have no vertical shift, so it is 0. How does that translate to our cosecant function? Well, in the same way it translated to our secant function. Since cosecant has no amplitude, we'll just write no amplitude. The phase shift is the same as for our sine function. The period is the same as for our sine function. And then our phase shift is the same as for, our vertical shift, I should say. Our vertical shift is the same as for our sine function. All right, so we have those two things. Let's see. How do we graph? How are we going to label our x-axis, since that's the very first thing we should do? Well, I'm going to go ahead and label it in red, and I'm going to start off by finding the beginning of this function. So I set x minus pi over 2 to 0, and when I solve I get pi over 2, and in the end, for the end mark, I set x minus pi over 2 to 2 pi. Okay, when I add that, when I add pi over 2 to it, I get 5 pi over 2. So I can see that from here to here, I have 4 nice bumps. If I label everything by pi over 2's, it'll work out really nice. So I get pi over 2, pi, 3 pi over 2, 2 pi, and then 5 pi over 2. So how many bumps did we have? 1, 2, 3, 4. If I go 4 backwards, I will be labeling another function, another period. I mean, negative pi over 2, that was 2. Negative pi, that was 3. And here's my last. Okay, so again, make sure that if you take the, if you subtract the beginning from the end, that you get your period. So let's just do that calculation. This was my beginning, and this is my end. 5 pi over 2 minus pi over 2, that's 4 pi over 2, which equals 2 pi. If this is my begin and this is my end, I get pi over 2 minus a negative 3 pi over 2, which equals 4 pi over 2, which is my period. So I calculated everything correctly. So make sure you do that calculation just to make sure that you're correct. So now let's go ahead and graph our sine function. I know for my sine function, at the beginning of my sine function, end in the middle, and at the end, I'm crossing my vertical shift. So I'm going to mark those points beginning, middle, and end. All right, so I know at the quarter mark, I'm up by the amplitude. So that is 3.5 in this case. So my quarter marks are the same for both periods. For my 3/4 mark, I'm down by my amplitude. So now I just dash that in. And this will help me graph my function. The next thing I do is I locate where the sine function crosses my vertical shift line, and I'm going to label these lines. These are my asymptotes. All right, so let's label them. All right, so now I'm going to draw in my secant function. If my sine function is above the x-axis or the vertical shift, I make upward parabolas. If it's below my vertical shift, I make downward parabolas, and that's how we're going to graph these. Okay, I have one more, and we're going to run through this one really fast. So let's go ahead and write this in terms of sine. All right, my little fast is not working out. We're going to go ahead and factor out that 2. I know that the amplitude is the absolute value of -2, so it's 2. I'm going to calculate my period, 2 pi over 2, which is pi. My phase shift is going to be -pi over 4, so I'm moving to the left. My vertical shift is going to be 1, and I do have a reflection because little a is negative, a reflection over the x-axis. How does that translate to my cosecant? Same thing, except I have no amplitude. My period is pi. My phase shift is -pi over 4. My vertical shift is 1. And I have a reflect across the x-axis. All right, so let's go ahead and find the beginning and the end. The beginning is going to be 2x plus pi over 2 equals 0. So when I solve, I get a -pi over 4. And the end, 2x plus pi over 2 equals 2 pi. When I solve, I get x equals 3 pi over 4. So let's go ahead and mark those on the x-axis. I have 4 marks going forward, so I'm going to label these. This should work out really nice. Pi over 4, pi over 2, 3 pi over 4. And if I go backwards 4 jumps, I get -pi over 2, -3 pi over 4. -pi and -5 pi over 4, and you should check that your begin and end when you do that subtraction actually equals your period, and in this case if I look at it and inspect it, it really does. All right, so now I'm going to go ahead and graph my sine function. I know at the beginning, middle, and end it crosses my vertical shift line, which is 1, so I should label that y equals 1. Okay, I've got a nice point here, 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 and lastly there. This is going backwards, or reflection, so it's going to be upside down. So I'm going to be down by my amplitude at my quarter mark. My amplitude is 2, so I'm actually, no, there, I'm sorry, I'm goofing this up. And then I'm going to be above by my amplitude at my 3/4 marks. So when I graph this in, my sine function is going to look like this, where it crosses the vertical shift. I get asymptotes, and then I'm just going to go ahead and graph my function in very quickly before my time runs out. it's below, it's above. Okay, I should